Alright, so I'm going to start the recording by showing you what I want the students to do initially. So I want the students to create a scene and then create a simple gray box prototype, and that's just for practice. So they'll create either create a new game entirely, or in the game they're already working on, they'll just create and open a new scene. If they don't remember how to open a scene, it's pretty easy. Just click on scenes, go to create, and then you should see scene, and they'll click on a new scene and it'll open up kind of this blank background for them. That's just review. So let's create a quick gray box prototype. I'm not going to do the whole thing recorded. I just want to remind you what we're going to be doing. So they'll create a floor, and I want the floor to be scaled at about 50. One is fine for the Y, 50, so it's kind of just a large platform. It's a good idea to color the floor. So something I'd recommend doing is creating a material. So you'll click on create and then just go down to materials. The reason you want to color the floor is especially for gray boxes, is if everything's the same color, white, it's really hard to see walls and things like that. And in this one, I want the students to be able to target walls and floors. There we go. So they'll be able to see the difference between floors and walls. Awesome. So I'm just going to create one quick wall for you, and then show you how I want the students to group the wall and the floor together. So, whoops. So I'll just create another cube, and I'll call this wall, and we will reset the positioning, and then position the wall at 25, and that should put it at an edge. Awesome. 25, and then I want it to be, I don't know, 10. Whoops. I want it to be about 10 tall and 50 wide. Now, it's kind of weird because it goes into the ground. It doesn't really matter. You can pull it up if you want to about the 5 level, and then that will capture it. Sweet. This is kind of easy. If you hold Control and press D, it'll recreate the wall. And then for the position, you just set this to negative, and that'll allow you to create the walls you're looking for. And if I copy the 2 walls I already have and then just rotate them by 90 degrees, and then instead of the positioning there, I'll just change this to 25 and this to negative 25. Awesome. All right, now I'll be back when I'm ready to made this scene look a little bit larger. The reason I did that is to give students more of a playground to work in. We're going to be using this scene as a gray box for a lot of things, especially once we get to AI. So we're going to test out. This is what we're going to get out of it. Let's play really quick so you can see. So with Raycasting, so what I did is I got the cursor hidden, and you probably can't see them. We'll go really close to this wall, but there's a little dot in the middle of the screen, so I created like a crosshair, and when you click, the left mouse click, it creates a sphere. Now that sphere will destroy itself after, I think I set it to be like a second. Yeah, a couple seconds it looks like. Okay, cool. The sphere will destroy itself, and that's a good way for them to see what raycasting does. So if I shoot at the sky, it does nothing. So raycasting is actually looking for a hitbox or a collider, and so it'll collide with wherever my mouse is and create the sphere. So this is what they're going for, and this is what I want them to have done before they start implementing in their quest. The reason for that is I think it'll give them a better context as to what raycasting actually does before they make it do something else. In video games, as I mentioned in the previous video, raycasting is in everything that they do, so it's going to be really important for them to get practice on how to use raycasting. So let's go ahead and take a look at... So there's only 2 new scripts, or 1 new script for this. We've got our normal movement script, and I'm going to add all these scripts to a folder that I put into our shared drive. Nothing's different about this one. I'm just going to keep them all together in the event you want to give the students the same thing you're using. There's also the look, so mouse look and horizontal look. The only thing that's different is first person input, and this is what I already went through with you in the previous video with raycasting. However, this one does something a little bit different, and so I'm going to go through a bit of the changes. First things first, we get the camera. Now, we already did that with raycasting previously when we were getting the screen point to ray. If we go down to start, I don't know if I did this in the previous video, but I'm turning the cursor off here. And that's so you can see the crosshair and there's no cursor in your screen. So that's what this does. The next thing we're doing is we're creating our crosshair. Our crosshair is really just an asterisk that we position to be in the exact center of our screen. There's other ways to do it. This is just an easy way that I do it in code. It's going to be the get mouse button 0. You've already seen that. The screen point to ray, you've already seen that. You've seen this, provided you watched that last video. This is the only thing that's different. So once the raycast actually happens, and remember, this is looking to see that we hit a collider. That's what makes this true. So if we hit a collider, then the coroutine starts up. And the coroutine this time, we haven't done this before. This coroutine actually has parameters. So what we're passing as an argument is the hit dot point. And if you hover over this, again, I don't think you can see the helper text in my video. It says the impact point in world space where the ray hit the collider. So it's a vector 3. It'll give you the exact position that the ray hit the collider, and that's going to be important later on. Here, when we start the enumerator sphere indicator. So what this is going to do is it's going to grab that vector 3 as a position, and we're just going to use Unity's built-in primitive creator. So a sphere is a primitive, just like a cube, etc. And so we are going to create this sphere, and then now that we created the sphere that we called sphere, we're going to be able to access that specific sphere and tell it which position we want it to be instantiated at. It'll actually create it. I don't actually know where it initially creates it, probably at like the origin, but this happens at frame speed. So before you actually see its creation, it'll toss it at this position. So since we've named it and we are accessing it in the same frame, then we can change its position there. And we can tell it what to do. So cool thing is, this sphere will destroy itself. I guess I have it set to 5 seconds for the specific sphere. So each time you click, it'll create a new enumerator that does all this cool stuff for that specific sphere. I hope that made sense. Yeah, good stuff. It's not that much. I hope the students understand it. I'm trying to see if there's anything different. So we're destroying the sphere that we created. We're telling the sphere that we created where to go within this enumerator. Yeah, cool. Again, they won't understand arguments and parameters. I meant to get a chance to teach this to them, but I didn't get to. Hopefully you can talk to them a little bit about the relationship between what's going on here, here, and here. So that this position is equal to this value here when this method is called, which is being given to it from up here. However you want to teach. But what I want them to do is be able to make a game. They're in a scene where you can jump and you can create spheres. So just like my student a few years ago created a game where they had to use these spheres to get to some platform really high up in the sky, I want them to think about what kind of game they could create where you can create things that you can walk on. And, you know, like I said, the baseline would be if they created some sort of game out of it where maybe they have to get to something that's underneath this main stage, I guess. I don't know, by creating what, I don't know. I'm just messing around with it. I want them to make a mini game out of it. Like, there's enough going on here that they should be able to create something pretty cool. Noah did something pretty dang awesome. He created like a wall climbing game, and then he made his character have the ability to glide and get to different spots, and he like traversed a lava thing. Ask Noah what he did. It was pretty sweet. I'm hoping the students have fun with this. I want them to have like one day to really understand what raycasting is, and then some time to make a toy out of it. Tell them that they need to change the code somehow. There's a few things that they're going to need to do to change the code. They might want to change how long it takes for these to decay, and that's fine. they might want to change the mouse press. So you can actually change the code where instead of mouse click, it's just mouse down. And it's kind of cool. It'll just create like a bunch of these spheres. Um, if they want to go super spicy with it, they can give the spheres code, which is kind of cool. You can attach a script to a game object that you create and code, and that's something they can figure out on their own if they want to be really spicy. But I really want them just to have fun with it and get engaged with what you can do with raycasting. I know this is a longer video for something kind of silly, but if you have any questions, please reach out. I want